Hello, how are you? Today is another beautiful day. Yesterday we tried doing some stuff and you saw that life was beautiful with maths. Today is a continuation of those classes yesterday. We'll still be looking at some problems. So more of problem solving. So based on what we have done so far, if you have had any problem, if you feel you have any problem, solving one or two things, I want you to please quickly send a message across so that we'll put more effort in explaining those areas so that you see that life is really beautiful with mathematics. As usual, today we'll still be expecting or hoping to see our friend, our brother, Mr. Autopress. Please, you are welcome on stage so that you can help us again. Thank you.
Okay, thank you. My name once again remains Autopress Prince. Today we want to look at some questions. Assuming you have this question, the limits as x tends to 4 of this function. What do we do? The first thing we are going to do is this. Of course, since it's a fraction, you know that if you substitute 4 into this expression, it will make the expression undefined. So we'll not do it that way. This is what we are going to do. We are going to factorize the numerator and the denominator. And if you do that, this is what we are going to get. X squared minus 16, applying difference of two squares, the result is going to be x minus 4, x plus 4, divided by x minus 4. We are taking the limit of it as x tends to 4. Now, the x minus 4 on top cancels out the x minus 4 beneath. We are left with x plus 4. So our final answer now becomes, and remember x tends to 4. So our final answer becomes 4 plus 4, which is equals to 8. You have this question given that f of x equals 3x raised by 3 minus x plus 5. You have to find f of minus 2. That's just substitution. What you do is this. We are given the function f of x is 3x raised by 3 minus x plus 5. And we have to look for f of minus 2. It means that anywhere you see x, you replace x with minus 2. So here I have 3 minus 2 raised to the power of 3 minus, anywhere you see x, write minus 2. So I'll write minus 2 plus 5. This will give me 3 into minus 2 raised to the power of 3 becomes minus 2 times minus 2 times minus 2, which is minus 8. Minus into minus 2, that will give us minus times minus, that will give us plus 2 plus 5. 3 times minus 8 will give me minus 24 plus 2 plus 5. This will give me minus 24 plus 2 is minus 22. Minus 22 plus 5 will give us what? Minus 22 plus 5. That will give us minus what?
17.
minus 17. This is my final answer. We have this question xy squared plus 3x squared equals to 10. You have to look for dy dx, find dy dx over dx. If x is equals to 1 and then y is equals to 1. Okay, this is what we are going to do. Of course, we learned differentiation, but we are going to differentiate this implicit function. How do we go about this? Very simple. Okay, this is what we are going to do. Here we are going to apply product rule. So this is what I'll do. We keep this one constant, differentiate this, plus keep this one constant, differentiate this. That is product rule. That's how you solve product rule. So we are going to apply product rule on this side to differentiate this. This is what we are going to get. I want to keep x constant. Then I'll differentiate y squared. If I differentiate y squared, I have 2y dy over dx plus keep y squared constant, differentiate x, you have 1 plus differentiate 3x squared, you have 6x, differentiate 10, you have 0. And so x times 2y dy dx, that is 2xy dy over dx plus y squared plus 6x is equals to 0. Remember, we have to look for dy over dx. So make dy dx the subject formula. 2xy dy over dx is equals to 0. Transfer 6x, that way becomes minus 6x minus y squared. My dy over dx now, divide both sides by the coefficient of dy over dx. Now, dy over dx now becomes minus 6x minus y squared over 2xy. Dy over dx now. Minus 6, that is minus 6 into x. What's my x? Is 1. Minus y squared. Y is 1. 1 squared over 2 into x is 1. Y is 1. Now we evaluate that. If we do that, minus 6 times 1 will give me minus 6. 1 squared is 1. 2 times 1 times 1 is 2. So I have minus 6 minus 1, which is minus 7 over 2. That's my final answer. But we can still reduce it. Minus 7 over 2 is the same thing as minus 3 whole number, 1 over 2. We have this based on limit of sine 3x over sine 7x as x tends to infinity. Now you have this. What do we do here? we cannot substitute. So we apply L'Hopital's rule. We are going to differentiate the up and the down. Differentiate both the top and the down. If you differentiate sine 3x, we have 3 cos 3x. Differentiate sine 7x, we have 7 cos 7x. After we must have done that, okay, x tends to infinity. So let me check. What's this? One question. This is not supposed to be infinity, this is supposed to be 0. Okay. So I've corrected the question. Now this is how it goes. I have 3 cos 3x, that will give me 3 cos 3 into 0 over 7 cos 7 into 0. This will give me 3 cos 3 times 0 is 0. 7 cos 7 times 0 is 0. This will give me 3. What is cos 0? Cos 0 is 1. So that will give me 3 times 1 over 7 times 1, which is 3 over 7. Final answer. Assuming you have this limit of 20 x squared plus 5, we are looking at limits. For x squared minus 7x plus 3 as x tends to infinity. Okay? Now what do we do here? What we are going to do is this. Very simple. That's what we are going to do. We try to locate the highest power of x in both the numerator and the denominator. We locate the highest power of x. The highest power of x, we have x raised to the power 2 here, we have x raised to the power 2 here, both the numerator and the denominator. So what we are going to do is this. We divide each term in the numerator with the highest power, which is x raised to the power 2, divide the denominator each term also by x raised to the power of 2. So this is what we are going to get. We have 20x squared over x squared plus 5 over x squared divided by 4x squared over x squared minus 7x over x squared plus 3 over x squared. So this you cancel out this you cancel out this. I'm left with 20 plus 5 over x squared, the numerator level, then 4 minus 7 over x divided x squared is x plus 3 over x raised to the power 2. But we are told that x tends towards infinity. Remember, 1 over infinity is equals to 0. 2 over infinity is equals to 0. 3 over infinity is equals to 0. So what we are going to do is this. We have 5 over, anywhere you see x now you write infinity. So what I have is, this will now become 20 plus 5 over infinity squared is 0. This is 4. 7 over infinity is 0. 3 over infinity squared is 0. So I have 20 over 4, and 20 over 4 is equals to 5, which is my final answer. if f of x is equals to x raised by 3 minus plus rather 4x minus 3. For x squared minus 3, determine, look for f of minus 1 plus f of 3. Very simple question. We are looking for f of minus 1 plus f of 3. First, let's look for f of minus 1. F of minus 1 is anywhere you see x raised minus 1. Minus 1 raised by 3 is minus 1 times minus 1 times minus 1, which is minus 1 plus 4 into minus 1 squared is minus 1 times minus 1, which is 1 times 4 is 4 minus 3. Then f of 3 now. Let me finish with this one first. This will give me minus 1 plus 4 times 1 is 4 minus 3. That will give me minus 1 plus 4 is 3. 3 minus 3 is 0. F of 3 now becomes 3 raised by 3 plus 4 into 3 squared minus 3. This will now give me 3 squared is 27 plus 3 squared is 9. 9 times 4 is 36 minus 3. So here I have 27 plus 36. That will give me what? 27 plus 36, that will give me 7 plus 6 is 13. That will give me 63. 63 minus 3, that will give me 60. That's my. So I have 60 there. Now f of minus 1 plus f of 3 now becomes 0 plus 60. 0 plus 60 is 60, which is my final answer. Now we have this question, find an equation normal to the curve x squared y plus y squared plus x plus y equals 0 at the point 1, 1. Okay, what are we going to do here? Now this is what we are going to do. First and foremost, for us to look for an equation that is normal to the curve, we need to get the slope of the curve at that particular point. Now, how do we get the slope of this curve at that point? For us to get the slope of the curve, we need to differentiate it. And if we differentiate this curve, this is what we are going to get. Apply product rule of differentiation here. What do we do? This is what happens. You have, keep this one constant first, x squared. Differentiate y, you have dy over dx. Plus, keep this one constant now. Then differentiate x squared, you have 2x. Plus, differentiate y squared, we have 2y dy over dx. Differentiate x, I have 1. Plus, differentiate y, I have dy over dx equals 0. Next thing I have to do here is this. X squared times dy over dx is x squared dy over dx. Y times 2x is 2xy plus 2y dy over dx plus 1 plus dy over dx is equals to 0. Collect all the like terms. What are the like terms here? I have dy over dx, dy over dx, dy over dx. So I write, say x squared dy over dx plus 2y dy over dx plus dy over dx equals 0. Take all the ones that are not like terms to the right hand side. When 2xy moves, it becomes minus 2xy. When 1 moves, it becomes minus 1. So I now factor out dy over dx. If I factor out it, what I have is dy over dx bracket x squared plus 2y plus 1 equals to minus 2xy minus 1. The next thing is I'll divide both sides by the coefficient of dy over dx, which is x squared plus 2y plus 1. So this is what I will get, dy over dx now equals to minus 2xy minus 1 over x squared plus 2y plus 1. That will give me minus 2 into what's my x? What's the value of my x? Now, okay, I will now substitute in these values. Where my x is 1 and my y is 1. X is 1, y is 1 minus 1 over, this becomes 1 squared plus 2 into 1 plus 1. Now minus 2 times 1 is minus 2. I have minus 2 minus 1. 1 squared is 1. 1 times 1 plus 2 times 1 is 2. So 2 plus 1 is 3 plus 1 is 4. I have 4, which is equal to minus 3 over 4. Now my dy over dx, the result for my dy over dx is minus 3 over 4 at that point. Now, the question says find an equation normal to the curve x squared y plus y squared plus x plus y equals to 0 at the point. Now, for an equation to be normal to the curve, there is a relationship. Their gradient, the product of their gradient must be equal to minus 1. The relationship between the normal to the curve and then the gradient of the curve. The gradient of the curve. The relationship is that the product of their gradient is minus 1. So now, we know that the gradient of the curve is minus 3 over 4. Now we say, let m1, which is equals to minus 3 over 4, represent the gradient of the curve. Since m1 equal to minus 3 over 4 represent the gradient of the curve, then recall, I told you that there is a relationship between the normal to the curve and then the curve. There is a relationship regarding their gradients, and that relationship is known as the condition for perpendicularity, which says that the product of their gradients will be minus 1. That is, m1, m2 is equal to minus 1. Now, my m1 is this, then my m2 is, my m2 now is going to be the gradient of the normal to the curve. Let m1 represent the gradient of the curve, and m2 represents gradient of the normal. Gradient of the normal to the curve. Normal to the curve. So we know that from mathematics, for the condition for perpendicularity for two lines to be perpendicular is that the product of their gradients must be minus 1. So m1, m2 is equal to minus 1. Now, my m1 is minus 3 over 4 times m2, which is equal to minus 1. I'll make m2 the subject formula. Minus sign, we cancel out minus sign. m2 now will be equals to 3m2 is equals to 4 when we cross multiply. Then m2 is equals to 4 over 3. So m2 is the gradient of the normal to the curve. Now that we know the gradient of the normal to the curve, the next thing is we now look for the equation of the normal to the curve. For us to get the equation of the normal to the curve, this is what you do. You say, you use this, y minus y1 is equals to n to x minus x1. Y minus y1 now is This is x and this is y. Y1 now is 1 equals to m2. My m2 now is the gradient of the normal, which is 4 over 3. Then x minus x1. My x1 is 1. So I have y minus 1 equals to I cross multiply. If I cross multiply, I have 4x minus 4 over 3. Next thing is this. Sorry, not cross multiply, I open the bracket rather, and that will give me 4x minus 4 over 3. Then the next thing is I'll cross multiply. So if I cross multiply, I have 3 into y minus 1 is equals to 4x minus 4. 3y minus 3 equals 4x minus 4. Okay, collect all the y's. Bring all this one to the left hand side. I have 3y minus 3 minus 4x plus 4 equals to 0. I have 3y minus 4x minus 3 plus 4 is plus 1 equals to 0. This is the equation of the normal to the curve. Thank you. Now we have another question here. Given that the displacement of a particle thrown vertically upwards is s, which is a function of t, equals to 12 minus 5t plus t raised to power 4. What is the acceleration of the particle at t equals to 2 seconds? Okay, what we do? Solution. We have s subtract t equals to 12 minus 5t plus t raised to the power of 4. What do we do? Very simple. Is s subtract t equals 12 minus 5t plus t raised to the power 4. This is what we are going to do. We now say we differentiate it. This is displacement function. Now we are going to differentiate this function to get our velocity function. So we now look for s prime of t. S prime of t means that you differentiate s of t. S prime of t means you differentiate s of t. So if we differentiate that, what do we get? Differentiate 12, I have 0. Differentiate minus 5t, I have minus 5. Plus differentiate t raised to the power 4, I have 4t raised to the power of 3. Then I'll differentiate this stuff again to get acceleration. If you differentiate your velocity, you have acceleration. And that will give us s prime of t. Differentiate minus 5, you have 0. Differentiate 4t raised to the power of 3, you have 3 times 4 is 12t squared. Remember, t is 2 seconds, so that will give me 12 into 2 squared. That will give me 12. What's 2 squared? 4. What is 12 times 4? 48 meters per second squared. That is my final answer. We have this question. Find the stationary point of the function y equals to 2 over 3 x raised by 3 minus 2x squared plus 1. Now, for us to look for the stationary point of this function is very simple. What we are going to do is this. We are going to differentiate. We are going to differentiate the function and equate it to 0. Differentiate this function once and equate it to 0. So this is what we are going to do. See dy over dx now equals to 3 times 2 over 3 s raised to the power 3 minus 1 minus 2 times 2s 2 minus 1 plus 0. So these 3 will cancel out 3. My dy over dx now equals to 2x raised to the power 2 minus 4x. Now, after we differentiate it, we equate it to 0. So I have 2x squared minus 4x is equals to 0. Then you look for the value of x. Let's factorize. What's common between 2x squared and 4x? Is 2x. 2x squared minus 4, what's common? Is 2x. 2x squared divided by 2x is x. 4x divided by 2x is what? What is 4x divided by 2x? 4x divided by 2x is 2 equals to 0. So we now say 2x is equals to 0 or x minus 2 is equals to 0. Divide everything by 2. If you divide it by 2, our x now will be 0 over 2 or x will be equals to 0 plus 2. X will now be 2 or x 0 over 2 rather is 0, x is 0 or x is equals to 2. Therefore, the stationary points are, find the stationary points of the function these are the stationary points. These are the points where the function will be stationary. These are the stationary points. At the point where x equals to 2, that function will be stationary. At the point where x equals to 2 and where x equals to 0, this function will be stationary. Thank you. We have this function. Locate the point of inflection of the function x raised by 3 plus 5x squared minus 10. What do we do here? Very simple. This is what we are going to do. Locate the point of inflection of the function x raised by 3 plus 5x squared minus 10. Solution. X raised by 3 plus 5x squared minus 10. We are asked to locate the point of inflection. You say y is equals to this. What we are going to do is this. We are going to differentiate this function twice. We are going to differentiate the function 2 times. So this is the first thing we are going to do. You say dy over dx now give us 3x squared plus 2 times 5 that is 10x. After that, we differentiate it the second time. We differentiate it the second time, we have d squared y over dx squared. That will give us 6x plus 10. Then you equate it to 0. Equate it to 0. You say 6x plus 10 equals to 0. Since 6x plus 10 equals to 0, it implies that 6x is equals to minus 10. When plus 10 moves that way, x now will be equals to minus 10 over 6. You reduce it, that will give us minus 5 over 3. So minus 5 over 3 is the point of inflection for this function. Thank you. Now we have this question. Determine the value of x at which the minimum point of the function y equals x raised by 3 plus 2x squared minus 3 occurs. What do we do here? Very simple. Solution. plus 2x squared minus 3. First thing is we are going to differentiate the function. Look for the y by the x of the function. To differentiate it, I have 3x squared plus 4x plus 4x. After we have differentiated the function, we now equate it to 0. Equate it to 0. You see 3x squared plus 4x equals to 0. This is a quadratic. This is a quadratic equation. So we factorize it. What's common is x. X into 3x plus 4 equals to 0. Implies that either x is equals to 0 or 3x plus 4 is equals to 0. X is 0 or 3x is equals to minus 4. X is equals to minus 4 over 3. These points where x equals to 0 and x equals to minus 4 over 3 are known as the critical points. Got the critical points? Got the critical points? The critical points are x equals to 0 and x equals to minus 4 over 3. Now, we are going to, for us to get the minimum points, for us to know the minimum points, what we are going to do is this. We are going to differentiate our differential the second time. We are going to differentiate our differential the second time, and then we are going to now substitute our critical points into that differential. So this is what we are going to do. We say d squared y over the x squared. This will now give us, we are differentiating this now. We are differentiating 3x squared plus 4x. So if we differentiate 3x squared, I have what? 6x plus 4. Now, we have gotten this result. We want to test which of these x values, will give us a minimum point, a maximum point. Now, what we are going to do is this. We are going to substitute the value of x into this expression. If the result is greater than 0, if the result is greater than 0, it's a minimum point. If the result is less than 0, then it's a maximum point. I'll substitute these two values into this expression I've got here. If the result is greater than 0, it's a minimum point. If it is less than 0, it's a maximum point. So let's do that. This should give me 6 into, that is when x is 0. When x is 0, now let's try it. I have 6 into 0 plus 4. That is 6 times 0 is 0. And 0 plus 4 is 4. But 4 is greater than 0. Because 4 is greater than 0, that is what? A minimum point. Minimum point. So this is actually our answer. They say determine the value of x at which the minimum point of the function occurs. The answer to this question is x is 0. It is only when x is 0 that we have a minimum point. We can test the other points. The other point will give us a maximum point. Let's test it. When x equals to minus 4 over 3. So you substitute minus 4 over 3 into the function. You have 6 into minus 4 over 3 plus 4. That is 6. 3 in itself is 1. 3 in 6 is 2. I have 2 times minus 4, that will give me minus 8 plus 4, and minus 8 plus 4 is minus 4. Minus 4 is less than 0. Since minus 4 is less than 0, we call it a maximum point. Maximum point. Our final answer is, therefore, they said determine the value of x. The value of x now is 0. It is when x is 0 that you have what? A minimum point. So your answer is, the value of x is 0. Take note. Thank you. Now we have this. We have this x. We have this based on given that f of x is 3x plus 1, g of x is s squared plus 1, and we are asked to do for f or g of x. What do we do? Very simple. Solution. Our f of x is given, our g of x is given, so f o g x simply means you put g inside you put g of x inside f of x. That is, put the whole of this. Anywhere you see x in f of x, put the whole of g of x. So this is what we are going to do. We have 3. Go to f of x. We have seen x in f of x. Carry the whole of g of x. Replace it with the x. So I have 3 into x squared plus 1 plus 1. That's my x. So the whole of this now becomes our x. Now this will give me, you expand. 3 times x squared becomes 3x squared. 3 times 1 becomes 3 plus 1. My final answer is 3x squared plus 4. That's the final answer. Minus 3x what is the value of dy by dx? Find dy dx. You have to look for dy by dx as well. What is it? Now, don't get confused with this. Y equals to 4t minus 3x. We are differentiating y with respect to x, not with respect to t. Not with respect to t. dy over dx now, because it is not with respect to t, this becomes a constant, and so it becomes 0. Differentiate minus 3x, you have minus 3. Finally, your dy over dx is minus 3. Take notes, don't get confused. we have this question. We have to look for the limits of this expression as x tends to 2. Okay? What do we do? Very simple. You know that if we should substitute 2 here, we are not going to get an undefined expression. So let's go by the substitution. We substitute the value of x as x tends to 2. We substitute x equals 2 into the expression. We are going to get this square root of, anyway say x right 2. That is 2 squared plus 8 into 2 plus 5 over 2 plus 7. This will give me square root of 2 squared is 4 plus 16, 8 times 3 is 16, then plus 5 over 2 plus 7 is 9. This will give me the square root of, that is 20 plus 5, 25 over 9. Square root of 25 is 5 over 9. This is my final answer.
Have you looked at implicit function?
Okay, we have this question and we are asked to look for the inverse of f. F of x equals 3x minus 9, and we are asked to look for the inverse of f. Okay, this is what you do. Very simple. Let's say f of x is our y, that is 3x minus 9. Now this is what I will do. Let's interchange x with y. Interchange x for y and y for x. That is, anywhere you see x, what I mean is that replace, anywhere you see y, replace it with x. Anywhere you see x, replace it with y. So I have y here, I'll replace it with x. I have x, I'll replace it with y. 3y minus 9. Okay? The next thing I will now do is this. I'll make y the subject formula. So I have, for y to be the subject formula here, I'll transfer minus 9 here. I have x plus 9 equals to 3y. The next thing is 3y equals to x plus 9. Divide both sides by 3. I have y equals to x plus 9 over 3. Now that my y is x plus 9 over 3, I will now replace this y with f inverse. So my f inverse of x now will give us x plus 9 over 3. This is my final answer. Assuming you have this function f of x equals 3x over x plus 4, and then you are asked to look for the domain of this function. Remember, you are going to consider, in looking for the domain, you first of all consider the real number, the set of real numbers. Okay? Now, this is a fraction, and because it's a fraction, what we are going to do is this. We are going to equate the denominator to 0. We are going to equate the denominator to 0. To find out what will make this expression to be undefined. So we say x plus 4 equals to 0, x will be equals to 0 minus 4, x is minus 4. Now, if we should put every other x values, input every other x values into this expression, we are going to get a corresponding y value. The only time we are not going to get a corresponding y value is when we impute x as minus 4. The only time we are not going to get a corresponding y value is when we impute x as minus 4. So the domain of this function, therefore the domain of this function, domain is all numbers except minus 4. All negative numbers will work. All positive numbers will work. The only number that will not work is when x is minus 4. So the domain of this function is all the numbers except minus 4. That's the answer. Thank you. Now if y equals to 1 minus 5x all squared, find y prime. Y prime simply means we have to differentiate y with respect to x. So what we are going to do is this. Let's use let's say u equals to 1 minus 5x. Then the u over the x now. Differentiate 1 is 0. Differentiate minus 5x is minus 5. And so what we have, u is 1 minus 5x, dx is minus 5. Then pardon me, our u is 1 minus 5x, then y rather will be u squared. The u dx now, the u over dx now is minus 5. Differentiate 1 is 0, differentiate minus 5 is minus 5. Then the y over the u now is 2u. Now we apply chain rule. The y over dx now is the y over the u times the u over dx. The y over the u now is 2u times the u over dx now is minus 5. Minus 5 times 2 is minus 10u, which is minus 10. What's my u? U is 1 minus 5x. Minus 10 into 1 minus 5x. This is my final answer. We have this question, evaluate this. We have to evaluate this. What do we do? Very simple. We are going to now integrate the function. If we should integrate the function, what do we get? Let's integrate cos x. That will give us sin x. Then we have 0, we have pi over 2. This is going to give us, anywhere you see x now, you write pi over 2 sine, pi over 2 minus sine. Anywhere you see x now, you write 0. This is sine. I is 180. 180 divided by 2 is 90. Sine 90 minus sine 0. What's sine 90? What's sine 90? Sine 90 is 1. Sine 0 is 0. So 1 minus 0 is 1. That's the answer. Now, we have this, and we have to integrate this function. We are going to apply integration by parts. Our u is going to be x because of lights, and our dv is going to be exponential minus 3x. So, our u is x. Our dv is exponential minus 3x. Our du now is 1 dx. Our v is exponential minus 3x over 3. Now, from the formula integration by parts, integral of u dv equals to uv minus integral of v du. So, it implies that the integral of x exponential minus 3x 0 to infinity is equals to, what's my u? X. What's my v? Exponential minus 3x over 3 minus integral of, what's my v? Exponential minus 3x over 3. What's my du? Du is 1 dx. And so I have x exponential minus 3x over 3 minus, bring out the 3 here, bring out the 3, so I have 1 over 3. Now if we integrate exponential minus 3x, I have exponential minus 3x over, that is I have, if you integrate that, I have exponential minus 3x over minus 3. Remember, if you integrate this exponential minus 3x, minus sign is supposed to be here. Supposed to have a minus sign here. Made a mistake. So here is carrying a minus sign. Okay? So if we should integrate, then this minus sign will change this minus sign. Here I have this minus sign will change this minus sign to plus. But then, if we integrate this one, the result is exponential. I have minus exponential minus 3x over 3 So the next thing is this. This will now give me this exponential x exponential minus 3x over 3 plus 1 over 3 times minus, that will give me minus exponential minus 3x over 9. Then put the interval 0 to infinity. Okay? We now substitute in those values. The first thing is anywhere you see x, you write this. So I have this exponential minus 3 over 3 minus exponential minus 3 into infinity over 9. That's the first. Minus anywhere you see x, now you substitute 0. That is 0 exponential minus 3 into 0 over 3 minus exponential minus 3 into 0 over 9. So I have, now what you need to know is that minus 3 times infinity is still infinity. Exponential of negative infinity is 0. So the whole of this expression is 0 minus 0 minus 0 times this is 0 over 3 is 0. Then I have exponential minus 3 times 0 is 0. Exponential 0 is 1, so I have 1 over 9. I have 0 minus 0 is 0. Then I have 0 minus 1 over 9 is minus 1 over 9. I have 0 minus 1 over 9. I have 0 plus 1 over 9, which is equals to 1 over 9. So that's my answer. We have this expression. We are asked to look at the limit of the function as x tends to 0. Of course, if we substitute x as 0 in this function, we are going to make the expression undefined, so we are not going to do substitution. What do we do? Very simple. This is what we do. We are going to differentiate the function. Differentiate it. That is applying L'Hopital's rule. Differentiate 2 sine 7x. We have 2 times 7. That is differentiate 7x, you have 7. Use that 7 to multiply 2, you have this. Then differentiate sine, I have cos 7x. Differentiate 5 is 0, so I ignore that. Differentiate 7x is 7. 7, we cancel out 7. I have 2 cos 7x. Now that we've got this result, we now substitute. So I have 2 cos 7 into 0. That will give me 2 cos. 7 times 0 is 0. 2 cos 0 is 1. Cos 0 is 1. So 1, that is 2 times 1. And 2 times 1 is 2. That's my answer. Y equals to sin x over tan x. Y equals to sin x over tan x. What do we do? How do we differentiate it? We have to look for the y over the x. Very simple. Y is equals to sin x over tan x is simply as sin x over cos x. So let's simplify that. That will give me sin x divided by sine x over cos x. This will give me sine x times, change the division sign to times, then take the reciprocal of sine x over cos x. That will give me cos x over sine x. Sine x, we cancel out sine x, we are left with cos x. So it implies that y is now cos x. And if y equals to cos x, you have to look for dy by dx now. Dy by dx now, if you differentiate cos x, you have what? Minus sine x. That's the answer.